Fourth grade, our next lesson will be 2 pages. So for me, that's 15 and 16. We're working on Module 4, Lesson 15, and this lesson is called Classifying Quadrilaterals. Both of these words might feel unfamiliar, but not for long. Pause your video if you need to, and when you're ready, we're going to start on new blank pages with our notes. Our objective says I can classify quadrilaterals based on its sides and angles. Classify means that I use qualities of quadrilaterals to put them into groups, and I make those groups based off of its sides and its angles. A quadrilateral is a 4-sided shape. Focus on the quad in quadrilateral. Doesn't it remind you of quarters? Like there are 4 quarters in a dollar, or 4 quarts in a gallon, or 4 quarters in a football game? These letters are a cue for the number 4. So a quadrilateral is a shape that has 4 straight lines. So now let's create some quadrilaterals. We're going to draw 2 perpendicular line segments, each measuring 4 units, which extend from point V. So I'm going to start in my top corner and create point V. If I'm creating 2 perpendicular line segments, that means that one of them is going to run horizontally 4 units, 1, 2, 3, 4, ends with an endpoint because it's a line segment. And its perpendicular direction, which forms a right angle, would be vertical 4 units. 1, 2, 3, 4. And I'll end it with an endpoint. I'm going to name these lines SV and UV. Now I'm going to draw a line segment SU, which means I'm going to connect my points S and U together at a diagonal. Imagine SU is a line of symmetry, meaning that I'm going to imagine that there's a mirror that's going to show the same shape on its opposite side of the line. Construct the other half of the figure. So that means that if this side has 4 units going down, so should its opposite side of its symmetry. 1, 2, 3, 4. And if it has 4 units going across, so should its opposite side of symmetry. 1, 2, 3, 4. I'll name this T. So what did I just form? I have a 4-sided shape, a quadrilateral, but I'm going to be even more specific than that. I notice that this quadrilateral has all of its sides the same length. I also notice that it has 4 right angles in each corner. So a shape with 4 right angles and 4 sides that are the same length, it's known as a square. A square is one of the first quadrilaterals that you've learned about before, but maybe you haven't thought about the definition of a square, so let's fill it in. A square is a quadrilateral with 4 equal side lengths and 4 right angles. Just like this shape here. So how does that make it different than this quadrilateral, which is a rectangle? A rectangle is also a quadrilateral because a rectangle is a shape that has 4 straight lines. And I noticed that there's a lot of similarities between the definition of a square and the definition of a rectangle. A square is a quadrilateral with 4 equal side lengths and 4 right angles, while a rectangle is a quadrilateral with 4 right angles. They're nearly identical definitions. The only difference is a square has to have 4 equal sides, while a rectangle does not. So for example, here's 2 sides of my rectangle, and here are 2 other sides of my rectangle. I have 4 right angles still. But these 2 side lengths are not the same as these 2 side lengths. I can also make a rectangle by making it go longer vertically. As long as I have 4 right angles and 4 sides, then it's a rectangle. Again, these 2 side lengths are the same, but these 2 are different. But since they all have right angles, these are all examples of rectangles. Can you draw one more example of a rectangle below? Remember that the lines of your rectangles have to be perpendicular to each other since you need to form right angles. Now that we've gotten some practice drawing squares and drawing rectangles, let's explore some other quadrilaterals that you might not be as familiar with. For example, a trapezoid, a parallelogram, and a rhombus. These are all different types of quadrilaterals, but they're going to look different from one another. Let's start with a trapezoid. For this trapezoid, let's make it 3 units going across, and we'll name these points A and B. I'm going to draw a parallel line to line segment AB, and I'll draw it below. But the difference is that I'm going to extend my line below. I'm going to make it 1 unit longer on both sides, right here and right here, and name the points C, D. Line segment AB is parallel to line segment CD. And remember that we can mark parallel lines using an arrow symbol like this. A quadrilateral has to be a closed shape though, so that means we need to connect these other points so that we have 4 straight lines. The 2 other side lengths are not parallel. I can tell because if I follow the lines of the side lengths, they will eventually touch each other. So I only have 1 set of parallel lines in this quadrilateral. But that's what a trapezoid is. A trapezoid is a quadrilateral with at least 1 set of parallel lines. A parallelogram is going to be similar with a little bit of a twist. I want you to imagine drawing a square. Let's make that square 3 units across like this. We'll name this line, let's say, EF. What makes a square is that it has to have right angles. So what if we tilted the square so that it didn't have right angles? For example, what if we made that square go diagonal? I'll go 3 units down, 1, 2, 3, and draw a new line that's offset by just 1 unit. And I'll call these lines G and H. Now I'm going to connect all of my lines together. This feels similar to a square, but because my angles are not right angles, they're obtuse and acute, this cannot be a square. So let's take a look at some of these side lengths here. I notice that line segment EF runs parallel to line segment GH. But I also notice it doesn't stop there. If I extended my vertical sides as well, I notice that line segment EG runs parallel to line segment FH. A parallelogram is similar to a trapezoid. They both have parallel sides, but a parallelogram has two sets of parallel sides. One set, two sets. Our last shape we're going to study today is a quadrilateral called a rhombus. A rhombus is a quadrilateral with, and I forgot the word with, so forgive me, with 4 equal sides and 2 sets of parallel lines. Just like the parallelogram, these both have 2 sets of parallel lines. But for a rhombus, it's really important that all the side lengths are also equal to one another. So let's practice that together. Let's start with a point up at the top. We'll call this point I. I'm going to count 3 over and 1 down like this. 1, 2, 3, and 1 down here. And we'll call this J. I'll connect the 2. Let's do the same thing over here, except we're going to go 1, 2, 3 down and 1 over. Ready? 1, 2, 3, 1. We'll call that K. We're going to imagine a little line of symmetry over here and draw the same shape mirrored on the other side. That means we're going to go 1, 2, 3 over and 1, like so. Call it L. And we'll connect all of our lines together. I noticed that JI and LK run parallel to each other. I also notice that JL and IK also run parallel to each other, but in a different direction than the first 2 lines. So now I see that this rhombus has 4 equal sides and 2 sets of parallel lines. That was a lot of information all at once, 4th grade, so make sure you're using your notes today when you get onto your problem set and your exit ticket.